So, what I want to do real quick is collate all of our data. So, we finished up the first part of the data collection here. And when I walked in, Chris jokingly said you killed my energy field rule. And I know, for example, when I ran the data, I got exactly 5 correct and 5 wrong. Michael crushed it with 9 and 1, 9 correct, 1 wrong. But I say crushed it, and this goes to what Kelly was talking about. One of these days, you're going to have a class to come in and blow my mind. I'm like, well, 9 out of 10 kind of blows my mind, but then I realized, if we were guessing, and I can justify that I pretty much was. I was basically trying to flip a coin in my head to decide, because I couldn't feel a damn thing. You're going to expect a 9 out of 10 every once in a while. It just so happened that Michael was sitting down and he was my 9 out of 10. If he was guessing, that's the whole thing. Was he guessing? I don't know. A data set that small will be impossible to determine, and you'll see why momentarily. So to collate all of our data into one big group. How are some ways I was able to control for bias in this experiment? Or I tried to control for bias anyway. Give me one way. When you read through this, it was pretty wordy. I mean, the experiment happened down here. But how did I try to control for any potential bias or inconsistencies? Give me one thing that we did in this experiment. What did the penny do, Drew? Go! Right, and what does that do? Make sure that we do? Good, not be biased because we're right-handed. It might be very easy to put your hand directly across to the person's opposite hand, more frequently than not. I've never tested that. It'd be fun to test. But the penny controls for that. And what I should have done, I didn't do this, was I should have had you indicate which heads and tails you got and then graph that. I'm sure it's going to be 0.5, 0.5-ish. Good, one way. Another way we try to control for it.
Standardize the question.
Standardize the question. Have you guys asked above which of your hands is my hand? Some of you may have been lax with that, it's totally fine. But that I tried to minimize bias so everybody's getting the same question. Not like, can you feel it? Try again. Try again. Not that. Trying to keep it consistent. Good. What's another way? What's another way? What's another way? It's a little subtle. Oh, good. I wasn't thinking about that. As random as we can be in here, right, Danielle? I mean, we're kind of 244 students, so we're kind of biased already. But yeah, just like pick a partner. I mean, most of you just turn to the person next to you, which is totally fine. Wasn't thinking about that. How about the description on, I didn't say put your hand above the person's hand. I said put it about 1 to 2 inches, trying to keep that measurement consistent. I mean, a couple times, me and Michael, when we were doing the experiment, our hands actually brushed. We had to throw that data point out because we were trying to keep it from 1 to 2 inches, trying to make sure if that field's there. I know nothing about it, but is it actually close? Is it you have to be close to feel it? I don't know. I don't know this. So I figured the closer the better, the closer we're going to feel it. One last way for consistency.
Didn't give feedback about success or failure.
Oh, good. 2 more ways. I wasn't thinking about that. Don't let them know if they succeeded or failed in the experiment, because then like, why was that important? Michael actually asked me this while we were doing the experiment. Why is it important not to give feedback?
You kind of guess on like what you're going to spend next.
It's quite possible. And sometimes we give feedback without realizing we're giving feedback. Like we might say things, I was telling Michael, I've done stuff in class. Did we do the Monty Hall doors? We did it in 105. I'm not sure if we did them in 243 with you guys, the Monty Hall doors. So the idea is I randomly select a door to put a lollipop behind. And then I come up and I ask the students, which door is it behind? And students have told me in the past, depending on where I put it, I'll tap my feet differently. Just random, and they're like, check it out. And I'm like, I can't check it out now that I know I'm doing it. Now I'm not going to think about it. Or I'm going to think about it and screw it up. But little things like that can standardize. Good. I wasn't thinking about that. The last thing I was thinking of was the clasp thing. When you clasp your hands naturally. The idea of that was to decide which was your energy dominant hand. I did some research into this, and that's what I read a couple different places. That's your energy dominant hand. So mine was left, which is interesting because I'm right-handed. Michael, you're right-handed, and his was right. So that's 2 data points that oppose each other. So I tried to be as consistent as I could across this experiment because it's such a contentious issue amongst psychological circles. Cool? Trying to standardize the experiment as much as I possibly could. Non-research psychologist that I am. Okay, so let's do this. What I'm going to do is let's test our data. Did anybody in any of the groups never get any of the answer choices correct? Like, did anybody go 0 for 10? Okay, nobody did that. Okay. Did anybody get 1 for 10 correct in their group? 1 for 10 correct? Nobody got that. Okay. 2 for 10 correct. 2 for 10. Anybody get 2 for 10 correct? So you correctly identified the hand twice out of 10? Nope. How about 3 for 10? 3 for 10? Okay, and that was 1 each. I'm assuming that's 1 each. So we got. So, okay, 1, 2, 3, nice and high. Nice and 3 for 10, correct? 1, 2, 3? Okay. Anybody have 4 out of 10 correct? 4 out of 10 correct. I'm just trying to collect, and let me know in your group, you each did it twice. So let me know how many, you got one of those, okay. 5 for 10, half of them correct. This was me. This was me. If you got exactly 5 of them, so 1, 2, 3, 4, 5, 6, 7. Beautiful. 6 out of 10 correct. 6 out of 10 correct. That's 1, 2, 3, 4. No, they did it again. 1, 2, 3. There we go. 7 out of 10 correct. 7 out of 10 correct. 1, 2, 3, 4, 5, 6. 8 out of 10 correct. 1. Chloe. 9 out of 10 correct. That was Michael and Will, it looks like. And 10 out of 10 correct. Nobody went off for 10. Or 10 for 10, I should say. There's our data.
It should be a 2 next to 9, right?
Was it 2 for 9?
Yes.
Oh, it was Will and, I'm sorry, Will and Michael. Yes, thank you, Will. Thanks for catching that. It's important to pull the average up. So now, that's our data. So that's the data I want you to slide into that histogram, or that distribution in the back. So this is our class data. This is our class data. It's kind of hard to test us individually on an average number correct, because we only have how many we got out of 10. So we're going to test that separately later. But for right now, we're just going to test as a class how we did. So that's the first part of the quiz, is just filling that distribution in. Hopefully that sums up to something close to the number of folks in the room this morning. Coolio? Now in class last time, the T interval that we ran was on Del Taco half-pound bean and cheese burritos. And it was just a list of weights that you fed into L1 and ran the function on. This is now a frequency distribution. I like these. I like these a lot. Because this is, in general, how data is going to come to you. And if it doesn't come to you like this, it's going to come to you in a histogram. That's part number 7. 7, create the histogram. And we're going to do it in the TIs to make sure you remember how to do it. We're going to do it in the TIs, make the histogram. Slide over here, zoom in, tilt up. Just because I want you guys to remember how to make a histogram for this data. All right, here we go. Stat edit. I've got some stuff in there from yesterday. I can get rid of it. Yep, just stat and then edit. That gets you to your right screen. Stat edit, and now you're in your L1, L2 screens. Let's see what we got here. 00031736120. Go on top of L1 or L2, press clear and down. That'll get the job done for you. Okay, thus far? So far, good. All right. Danielle, go ahead.
The bucket on this one.
Let's try something, because we have to do something different for us, and it might be different for you as well. If not, just default to 1. But it defaults to 1, yeah. Is there a way for you to call different lists? So I'll come back and take a look in a sec. Second y equals gets you to your stat plot menu. Second y equals gets you to your stat plot menu. And we're going to use the same 2 plots. I want to do just like we did last time with a histogram and a box plot. I want to do the exact same thing in both, but I'm going to turn the box plot off right now. So I'm going to plot 2 and turning it off. And the reason is I want to get the histogram dialed in first. And once the histogram's dialed in, we'll go back and turn the other one back on. It'll just get in the way right now. It'll be a visual kind of a headache to look at. So second y equals again. See how just plot 1 is on now? That's what we want right now, for right now. Select it. Everything's going to be the same, except for what? Who sees what has to change? Be brave, my friends. Please.
Put your X list, well, it should be L1, and then the frequency should be L2.
Perfect, Ryan. Frequency list has to be L2, because that's where your frequencies are. We can't leave frequency as 1. This is what I was asking about. I don't know if yours has a Y list, X list thing in there, Danielle. It might not. In case you make the bucket 1, that's fine. We'll see. We may have to adjust it some way. We'll figure it out break. So change your frequency to L2. There we go. Now we're ready to go. If you don't change the frequency to L2, what happens? If it stays at 1, what happens then?
You only get L1's worth of data, right? Just like the
Yes! It will simply graph 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, uniform distribution. That's not what you want. You want to see this. So, zoom 9, zoom 9. There is a histogram. I personally don't like it. I like finagling with them. I like making, I'm going to make them 1 unit wide each. If that's okay with you guys. I'm going to change the buckets, Daniel, if you go to 1. So the reason why I don't like this is the TI always gives you 7 bins, 7 bars. And if you press the window button, this is how you can tell it gives you 7 bars. The X scale is how wide each bar is. It's kind of annoying. It's kind of annoying to have it at 1.66 wide when your data is whole numbers like this. You see my complaint with that? I'm going to make it 1 wide for starters. And see the X max at 11.66666? I'm going to change that to just 11. And some of you are going to say, wait a minute, Rule, why aren't you changing it to 10? Which is the logical choice, correct? May I answer that question in about 30 seconds? Unless you know the answer to it already. Some of you might know the answer to it already. We'll answer it in a second.
0 there.
Say that again.
There's a 0 in there.
There's a 0 in there, which means you actually technically have to go to 11. Well, I think it will help with the visual. Press graph. There. Now I see 1 bar per data point. Per data point. And the reason I like this is the 0 is right here. This bar, which would indicate how many zeros there are, actually goes from 0 to 1. The bar that shows where the 1s are goes from 1 to 2, 2 to 3, 3 to 4. So the bar over here that shows where the 10s are has to start at 10 and go to 11. If you don't have 11 there, you won't ever see that last bar. Does that make sense?
Yeah.
So you have to have 1 more number than the number of bars because it has to see that last bar. Cool? There's our data. You can feel free to finagle. You can change that X scale to 2 if you want to group things together. There's your histogram where the stuff is grouped together by 2s. It's up to you. I like the 1 personally. That's just my personal opinion. I'm changing the X scale to 2, and what that does is instead of each bar being 1 wide, it's 2 wide. So the first bar wouldn't be 0 to 1, it'd be 0 to 2. I changed it back now to the original one. Yeah, exactly. That's what mine looked like too. And I'm saying finagle because you get a slightly different view depending on how you group. Of course, you can also group so that you lose all indication and all of what your data looks like. You make 5. Ooh, there's an histogram for you. 2 bars. It was useless. Useless. Please.
Mine's not perfect.
Wait, was he giving you an error?
Yeah, same didn't mismatch.
Check your lists. When you go to second y equals, it has to say L1 and L2, and your data has to be in L1 and L2. That's the dim mismatch.
Okay.
So make sure your data is in L1 and L2. I'll take a quick look and see if that's what's going on. Okay, L1 and L2 is perfect. That, edit. Okay, that looks good. Right there. You got that extra stuff underneath. So just delete those extra little values and everything's fine. Cool? Mismatch just means there's not the same number in both. That's all that was. Cool?
Yeah.
Fair enough?
Yeah, well,
Okay, so what do you guys think? Let's answer question number 8. Does the data appear to be bell-ish shaped?
Yes.
Bell-ish. It's ish. Yes, it tends to have tails on the ends. It tends to rise up towards the middle. It's not perfect. It's not perfect. Untrain those algebra minds of yours. This is not a factorable quadratic expression. This is not the quadratic formula. This is not FOIL. This is a bell-shaped data set. It's a bell-shaped data set. I'm happy with that. I want to answer one more question before we take our break. Should we be concerned about any outliers? Or do there appear to be outliers in this data set? Do there appear to be outliers? Dina says shakes her head emphatically no. I'm tempted to agree with her. It doesn't look like anything's goofy. We got some loaded down here, but that doesn't seem like outlier. I'd be interested if there was a 0, but the 3 doesn't bother me all that much. I'm going to make one quick graph on top of this one. The box plot, the modified box plot, real quick, just to kind of soothe my heart about this. So I'm going to turn plot 2 on. Everything's almost ready to go from last time, except I have to change that frequency list to L2. Is he behaving now, my friend? Good, 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 good. All right. So I've got my modified box plot set. I may have to adjust my window a smidge. Yeah. So my question is answered, though. I want to raise my Y max a smidge to 12, just to get the box plot off of the histogram. I'm feeling pretty good about this. That box plot's almost perfectly symmetrical. The median's almost dead center. There are no apparent outliers. So Will and Michael's 9 and the 3s don't appear to be pulling unusually in either direction. I'm happy with our data set. It's about, Dino, what's on your mind? That was kind of like a, what he's saying. What's on your mind, my friend?
Yeah.
It looks a little different?
Mine does, not mine.
Oh, it's just because you guys zoom statted instead of hit graph. If you guys hit zoom stat, it's going to look like that. But the problem with zoom stat, here's my TI lesson for graphing. I'll press zoom stat the first time, when I first put data in. Then whenever I say finagle, and I start finagling, I never push zoom stat again. It's always graph at that point. Because then, if I press zoom stat, I lose all my finagling. Go ahead, Rosie.
I didn't do zoom stat, but it's still, it looks like the last bar.
That's okay, we'll figure it out at the break, I promise you. We'll figure it out. Cool? So I'm happy with our data set. Let's test it when we get back from break, yeah? Take 5, go get some air, go get some water. And let's figure out any TI issues.